Hello, and welcome to a little video about Target 6A, where we're going to be looking at geometric sequences as exponential functions. Now, the first thing that we do, or actually we did this in class together a couple days ago, is we reviewed what exponents are. So just for the sake of this video, let's talk about it a little bit. Exponents are the exponents of a number says how many times to use that number in multiplication. It's written as a small number to the right above a base number. So the exponent is telling us to do quick multiplication. For example, 8 is the base, 2 is its exponent, that means multiply 8 twice. If we had 9 to the power of 4, that means 9 4 times. All right. A lot of this is done on your calculator. If you want some help on how to do this in your calculator, I'm happy to show you individually, but I cannot screen record two things at once, so just imagine me doing this in a calculator. All right. And the very first thing we practice together is putting all these numbers into the calculator. So the way we do it is we would click 2, we would type our little caret, and then you type 3, you get 8. I'm going to go down and fill these in. If you are following along with this video and taking notes, maybe take a second to pause and calculate this yourself, and then fill it in. But I'm going to go ahead and do it. Just a fair warning for you to pause. Okay. We also did the 3 to the power of. Beautiful. We also did 1/2 to several powers. Okay. So, after we filled this out and took a look at it, I asked this question. What do you notice about everything to the power of 0? And most folks were able to tell me that an exponent with an exponent of 0 gives us an answer of 1. Now, negative exponents, what do they do to our whole numbers? Well, they make our whole numbers into fractions, and what do they do to their fractions? They make them to whole numbers. So if we have a whole number to the power of a negative exponent, we flip it to the bottom of a fraction. And if, for example, we had b to the power of negative n on the bottom of our fraction, we would flip it to the top. A last little rule that I kind of wanted to go over with everyone, even though you don't need to memorize this, is fractions with exponents. When we have fractions with exponents, we give each part of the fraction, so the numerator and denominator, an exponent. So a gets a power of n, and b gets a power of n. All right. Now, exponential functions. Exponential functions come in the following standard form. F of x equals a times b to the power of x. A is always our starting off point, it's our y-intercept, and b, our base, is always a positive number, or equal to 0. If we ever have a negative number, it's actually -1 times a positive number. So, I'm going to highlight this in green and this in blue. Now, in number 1, for this graph, it just says 4 to the x. What it really means, or really has, is 1 times 4 to the power of x. So it has that invisible 1 out in front of our function. We just don't write it. So let's fill this table in. Now, in a perfect world, I would be able to split the screen and show you how I'm doing this on my calculator. Maybe I'll make a video of that separately. But just imagine I've put this in my calculator. All right. So we've got 0.0625, 0.25, 1, 4, 16. Do you see how our 0 has a 1? That's the exact same 1 that was invisible in front of 4 to the power of x. Now, when I'm graphing this, I'm only going to graph my whole numbers because I don't feel like estimating my decimals. All right. So 0, 1 is right there. 1, 4 is here. And 2, 16 is there. Now, when we graphed it in our calculators as a class, you saw what the shape turned out as. I'm going to attempt to draw it. It's not beautiful, but it's like a swoopy. A hyperbolic kind of form. All right, let's take a look at number 2. Number 2, just like number 1, 1/3 did not have a real number written in front of it. Or, sorry, a visible number written in front of it. So I'm going to rewrite that invisible 1 just to remind us where our y-intercept comes from. Okay. When I put this in my calculator, for the power of -2, I got 9. For the power of -1, I got 3. My y-intercept is that same 1 that I had highlighted in green. When I have the power of 1, it's 0.3, and the power of 2 is 0.1. Once again, I'm just graphing the whole numbers. 0, 1. -1, 3, and -2, 9. Number 3. Now, number 3 has a visible number in front. Let's see how that influences our y-intercept. All right, when I raise this to the power of -2, I get 0.2. When I raise it to -1, I get 0.7. When I raise it to the power of 0, I get 2. Yes, that very same 2 that I have highlighted in green in the function. When I raise it to the power of 1, I get 6, and the power of 2 is 18. I'm only going to graph these 3 points, because they're whole numbers. 0, 2, 1, 6, and 2, 18. Beautiful. Lastly, let's graph number 4. If it lets me scroll. May I scroll, please? Thank you. All right. Now, number 4 has a number in front of those parentheses again. That is going to influence our y-intercept. When we plug in -2, we get 12. With 1, we get 6. With 0, we have 3. That same 3 that was in front of those parentheses. For 1, we get 1.5, and for 2, we get 0.75. I'm still only going to graph my whole numbers. All right, 0, 3, -1, 6, and -2, 12. Fantastic. Notice how all the numbers in front were always our y-intercepts. Using that same logic, let's take a look at these 4 graphs and match them. Now, the first thing that I'm going to do, without looking at the y-intercepts, actually no, I'm going to. I changed my mind. Ignore what I just said. I'm going to look at every single y-intercept and I'm going to write it down, and that's going to help me match my graphs. Okay, let's start with this one. That has a y-intercept of 2. -1. That's 1. And this is 4. All right. Remember, the intercepts come from the number in front. So for letter A, there's nothing in front of the parentheses. But what number is actually there? Trying to draw it in. It's a 1. So, which graph has a y-intercept of 1? That graph. Letter B. Which one has a y-intercept of 2? That one. Letter C. Which one has a y-intercept of 4? That one. And letter D. Which one has a y-intercept of -1? That one. Number 6. For number 6, we're going to write our exponential function by finding A, the y-intercept, and B, our pattern. In this first table, it's easy to find the y-intercept. There it is. Hello, y-intercept. That's our A. So we can start immediately by writing f of x equals 2 times. Now, our exponents are multiplying. So to undo multiplication, I'm going to do some division to see what the pattern is. So to find out how I got from 2 to 6, I'm going to do 6 divided by 2, which is 3. Awesome. Let's check. 6 times 3, is that 18? Yes. 18 times 3, is that 54? Yes. Okay. So our function is 2 times 3 to the power of x. You can write it with a dot or parentheses. All right, second table. Once again, we have 0, 3. There's our A. Now let's find out what B is by doing some division. All right, to find B, I'm going to do 0.6 divided by 3, and I get 0.2. Let's make sure that works, okay? 0.6 times 0.2, yes, that's 0.12, perfect. Let's try one more. Let's do this one. 75 times 0.2, it's 15. Okay, awesome, we got it. So our function, f of x equals 3 times 0.2 to the power of x. Last one, we do not have a 0 here, but that's okay because we can figure it out anyways. So let's start off by just doing, let's just do some dividing, right? I'm going to start on the bottom here. Let's do, what's 67,228 divided by 9,604? 7. All right, let's see if that's the pattern. 28 times 7 equals 196. 196 times 7 equals 1372. Sweet. All right, let's do the last check. 1372 times 9 times 7. I don't know why I tried multiplying by 9,000. Is 9,604. Perfect. So multiplying by 7 is our pattern. Well, in order to go backwards, because I need to go one step back to get where x is 1, I'm going to do division. So to go this way, I'm going to do 28. Why won't you write? Oh no. Did we freeze? Oh, okay. I think my pen died. Alright, we're going to do 28 divided by 7, which gives us 4. Fantastic. This means our function, our function is 4 times 7 to the power of x. All right, that's all for this lesson. If you have any questions, please feel free to ask myself or whoever your math teacher is or whoever's helping you. One way or another, have a good rest of whatever day it is for you. Bye!